All right, now for what is probably the most important lab, especially the most important lab so far, is the Lego Brick Lab. Be sure that you have completed this lab correctly, because we are going to be using it for other assignments, at least a couple of them. So if your Lego brick is not done right, or it's messing up, or anything like that, make sure that you get it fixed and you get a good Lego brick, because otherwise it's going to impact other assignments. So we're not just going to be making a Lego brick, we're going to be using parametric modeling so that we can create a Lego brick that we can change. And we're going to change it with just a couple of parameters. So we're going to make a parameter that's going to be controlling the peg's width and the peg's length. And that's the number of pegs and the length and the width. Depending on what we put in for those values, that's going to decide the length and the width of the brick. And it's going to control a lot of other features as well. We'll also have another parameter for the block height. And then down here, your model will need to be valid for any number of pegs from 2 to 2 to 20 to 20. So if we put in 2 by 2 for 2 for pegs width and 2 for pegs length, your block should change. If we put in 20 for those values, it should change as well. So the Lego brick that we are looking at is going to be based off of this drawing. Hopefully everyone knows what a Lego brick is supposed to look like. So we have some information up here, but look at the reference geometry that we have. So we're not going to put in a value for the length or the width of the brick, or the height of this boss. This boss on the backside, we're not going to put in a value for that. So let's go ahead and open NX and get started. I'm going to make sure that we are in the advanced role. Go to new. We want a model. We want it to be in millimeters. We want to save it to a location that we can access later. And we want to name it Lab 5 UUID. And we can go ahead and create this. Again, we want to have a plan of action for creating this. So if we look at this working drawing, we kind of think about step by step. So we have a block here that has a 9.6 height. We know that the peg height is 1.8. We could probably start off with this rectangular box here. From there, we know that the inside is empty. And we have a shell thickness of 1.2. We could probably do that next. And then start creating some of these features. We're going to be using a lot of pattern features to create this. And then some mirrors. And we're really going to use a lot of the commands and the techniques that we have available to us, so we don't have to draw every single one of these. And also so we can use the peg's length and peg's width to either create some of this geometry or not create some of this geometry. So really what we want to do before we even start a sketch is we want to go ahead and address the peg's length and peg's width parameters. So we can go to our tools, expressions, or just Control E. And we can make our parameters. We have peg's width. This is going to be on the type. We can switch this to an integer. And for the time being, for peg's width, we can put in 2. And then we have peg's length. Again, this is just going to be an integer. And we're going to put in 4. Block height. Block height is going to be a number, and we're going to put in 9.6. And we'll hit OK. Now we can go ahead and start making our brick. So I'm going to go to Sketch. I'm going to start on the top plane. And I'm going to create a rectangle. I'm not going to have the rectangle start in the middle. I want my origin to be in one of my edges. So I'll start in this first quadrant. And we already have a problem, because if we look at our drawing, this is dimensioned based off of the values that we have here. So we immediately need to find a way to turn the pegs, the number of pegs, into these dimensions. And we really have all the information that we need. So this is a 2 by 4 pegs brick. We are told the spacing between the individual pegs and the spacing that is between the last peg and the edge of the brick. So for instance, this is a 4 peg in the length. And so we would have 0.8 between, or we would have 8 millimeters between this, 8 millimeters between this, 8 millimeters here. We would have 3.9 from here to the edge, and then 3.9 from here to the edge. And that's how we can get the 31.8. If we look at the width, we have 2 pegs, so it's going to be only one of the 8 millimeters and still 2 of the 3.9s. So I'm not going to show you the expressions that we need to put in for the actual brick length and brick width, but you have everything that you need right here. So go ahead and put your equations in for the parameters. Mine, I labeled one of mine brick length and then brick width, and that's based off of the number of pegs in the width and the number of pegs in the length. Use the 31.8 and the 15.8 to check your values. So when you put in 4 pegs in the length, you should get 31.8 for the brick length right here. And then you should also get 15.8 for the brick width when you put in a 2 for brick width. So use those to check your values. So I'm back at my sketch, and I'm going to dimension this, our brick length. And then here I will do our brick width. Now I can extrude this, and I want to extrude this a value of our block height. Okay. Now if I do any of these other features before I somehow shell this out, what's going to happen is I'm going to get the thickness of the shell in areas that I don't want the shell thickness to be. So the next step has to be to create this shell. So what I'll do is, now this is a new command for us. I'm going to come into the shell command. So the shell, we have a couple of options. We can do a close, and you can kind of see what's going on there. If you look at it from the outside, nothing's changed, but it's actually an empty shell on the inside. If we do open, it actually creates an opening, and then we get to determine the shell thickness. So we want an open, and we want our shell thickness to be that 1.2. And the face that we want to select is the open face. So I actually have this flipped upside down because we want this to be the open face. So we can hit OK. Now we have that 1.2 millimeter shell thickness that we're told here. And now we can start to put in some of these features. So let's address these top bosses first. Let's address the pegs first. We'll be on the top side. And then once we have that, we can flip this over and look at the bottom. And this is why it was important to have the origin on the side, because we're going to be addressing this a lot. So we want to make our first boss in the same corner as our origin. Okay, so this is my origin over here. So my boss is going to be right here. Then we're going to use the pattern feature to create the rest. So we're only drawing and extruding one and then we're going to use pattern feature to create the rest of them. That's how we can change from a 3x3 to a 30x30 brick. So I will start a sketch. And I want the sketch to be on the top surface. And if your origin is not at this corner, make sure that it is. Again, you can come over, specify origin point, and just make sure it's the corner, same corner as the origin of the model. And we're going to come do a circle. And I'm just going to place a circle on the surface. We have a diameter of 4.8 millimeters, and it's positioned 3.9 millimeters from the left wall and 3.9 millimeters from the bottom edge here. And I want the distance from the horizontal axis here to the arc center to be 3.9. And from the vertical to the center also to be 3.9. Our sketch is fully defined. We can hit finish. And we can extrude this out to 1.8 millimeters. And I can't change it because we have put in the block height before. So whenever we do an extrude or we're using a parameter, it's going to remember that and expect us to use that same parameter the next time we create an extrude, which is not always the case. So we can change this by coming over here to the equal sign and coming down to make constant. Now we can actually change that value. So that value is going to be 1.8 millimeters. I want to make sure that we're uniting that with the block, and we'll say okay. And now what we want to do is create a pattern feature. So allow us to take this feature that we've already modeled and pattern it so that it is copied for however many instances we want. And so we're going to be asked to select a feature. The feature that we want is what we just created, that boss that we just created. And we'll have a layout to select. We want to select linear. We'll go to our first vector here. And remember, whenever we specify a vector, the purple thing's going to pop up. We can select a direction, or we can just select the line, one of the lines that's on our block. We want to choose the line that's going in the length. We'll do that first. So the long way here. I'm just going to select that edge point. And it's moving to the left. I want it to be moving to the right. No big deal. Go over here to specify vector, and there is a reverse direction. We'll just reverse that direction. And that's good. We want a count in pitch. The count is going to be the number of pegs that are in the length. And we have a parameter for that. We have pegs length. So we're going to say pegs length. Right now that should be 4. And the pitch distance, we also know that we're told that between each of these pegs is 8 millimeters. So instead of the 10, we're going to put in 8. And now I hit tab. And remember, whenever we do the pattern feature, these little cubes are each of the instant points. And that looks about right to me. We've got 4 of them, and they look correctly spaced out. Now what we can do here is we can create like a sort of matrix, a 2D matrix. We've got the length, but we can also do the width. So we have this here. We have use direction 2. We're going to check that box. The vector that we want is for the width. I'm going to choose the line that's going in the width direction. And again, it is going in the wrong direction. That's fine. I'm just going to reverse that direction. This time, we still won't count in pitch, but the count, we're not going to use peg's length. Instead, we're going to use peg's width. And our distance between each of the instances, our pitch, is, again, 8 millimeters. I'm going to hit tab so I can see the instances. And that looks right to me, so I'll go ahead and hit show results. And that looks about right. So I'll hit OK. Now if we change peg's length to 50, we're still going to generate 50 pegs in the length. And not only will the number of pegs change, but also the actual length of the brick is going to change because we're basing this length off of the number of pegs. Remember, I didn't show you that equation, but I told you all the information that you need to know to get that figured out. All right, so now let's move on to some of the features that are on the underside of this brick. So I'm going to flip it over. I'm still going to be mindful of where that origin is at. I want to be sure that whatever I create down here, it is in this corner. So next, let's look at these embossed circles on the other side. So these actually kind of cut into those pegs that we just made. So let's go ahead and make those. We're going to do something very similar to the way that we did the pegs. We're still going to use pattern feature, but the way that we create the first one is a little bit different. So we're going to create a sketch, and we want to do it on the face of the extrude here. And I still want the origin of the sketch to be in the corner where our actual origin is. So I'm just going to place it there. I'll hit OK. And what's happened already is that NX is allowing me to see this sketch right here, which is really nice because I want to be able to reference this sketch. If you can't see this sketch for some reason, if you go to view and you go to static wireframe, you should be able to see those pegs. Since we can see it in the shaded wireframe, I'm going to keep it like that. And I want to create this 2.6 millimeter circle right here, and I'm just going to emboss it into the 1.7 millimeter depth. I'm going to make a circle. And I am just going to place it somewhere on this sketch. And this is 2.6 millimeters. And then what I want to do, I'm going to bring it over here. I want to say that the center of this circle lines up with the center of this circle here. I want them to be concentric with each other. And I'm going to use our make constraints. So I want to make sure that I have create persistent relations turned on. And I want a coincident. I want a make coincident. That's going to allow me to select one point and another point and have them be at the same location. So the first point that I'm going to select is the center of the arc that we just made. I want to make sure we're selecting the center. The second point that I want to select is the center of this circle, but I can't select it. We need to go over to our filters, make sure that we are in work part only, and now we should be able to select that center. We'll hit OK. And sketch should be fully defined. We can hit finish. We will extrude this. Make sure that we are reversing this direction. So we're going into the material. We are going down into the material 1.7 millimeters. Make sure that we are subtracting, and we can hit OK. So we are removing that material. Then we can use our pattern feature. Same way that we did the pegs on the top. So the feature that we want to select is that emboss that we just made. Let's choose a vector. I'll use the arrows this time. We still have the peg's length and peg's width on our counts, and we should still have the 8 millimeters on our pitch distances. So I went ahead and selected the peg's length first for that vector, and then for the second vector, I want to select the direction for the peg's width, which is going to be in this direction. You can see the cubes for our instances. We can go ahead and select our show results, make sure that everything looks right, which to me it does. We can hit OK. Now let's work on the bottom pegs, which are these round features here, these 3 that are in the center of the embosses that we just made. And then we're also told that these are going down the 8.4. The 8.4 is in parentheses, so we can't use that as a value. So we can't say that it's going down 8.4. We're going to look at another way to create an extrusion. Let's go ahead and start that. We know that the inside circle is 4.8 millimeters and the outside is 6.5. So we're going to create another sketch. Still on this, the bottom inside of our brick. This time we don't need the origin of our drawing to be lined up with the origin of our part. We do still want to keep in mind that this is the origin. So I'm going to have the origin of our sketch be in the center of this peg, the inside emboss that we made. And I'll hit OK. So we've got our first circle here. I'm going to say that this is the outside circle, which we're told is 6.5 millimeters. And I want this to be in the center of these embosses. But what I'm going to do is I know that the distance between each of these is 8 millimeters. So I'm going to create a dimension between this point and the center of our drawing here. And I'm going to say that's 8 divided by 2. I could put in 4 millimeters, but again, I want to keep track of what I'm doing. I want to document the process. So I'm making a decision here to dimension this half of the 8th, but I'm going to put equals 8 divided by 2 instead of just the 4 to make it clear, hopefully for someone if they need to change this, to explain why I chose to do that. I need to select the center of this circle and then our origin. And the first I'm going to do this. I'll do equals 8 divided by 2. And then I'll do this again. So this time I'm going to do the vertical. And again, I'll do equals 8 divided by 2. Now we need the inside circle. That is going to be 4.8 millimeters in diameter. I'm going to do a make coincident between the center of the circle we just made and the center of the first circle. Sketch is fully defined. I'll hit finish. And then I want to make an extrusion of those lines. And it automatically knows we want to extrude the area that's between this, which is great. And we want this to go until the bottom of the brick. And we're told that or the reference that we're told is that 8.6 or the 8.4 distance that's right here, but it's in parentheses. It's a reference, so we can't just type in 8.4. What we need is a way to specify that I want this to extrude the distance until it reaches the bottom of the brick. So if we go to value here for end, we've got until next, until selected. These are both good if the extrusion is actually going to make contact with the surface that we select. In our situation, the extrusion is never going to make contact with the bottom of this brick. It's just going to keep on going. So we want to do until extended. So until extended is going to essentially create like a plane on this top surface here. And if the extrusion contacts that plane at all, it's going to stop. So we're going to do until extended. We're going to select the bottom of the brick. We'll go ahead and just say show results. That looks good. So we'll hit OK. And we're not done yet because, again, we want to do a pattern feature of this. The feature that we want is the boss that we just made. Still want a linear. We're still in peg's length, but see, if I select peg's length right now, we've got 4 of these, which isn't going to work because we only have 3. So we've got the one here, one in the middle, and the third one here. But if we think about this, if we had 5 pegs here, we would then have 4 of the bosses, of the ones that we just made. If we had 6 of the pegs, we would have 5 of these bosses. So we'll always have 1 less than the pegs that's specified. So instead of saying peg's length, we're going to say peg's length minus 1. So I'm going to go ahead and specify the vector that I want. And I'm going to change this to constant. And I'll say peg's length minus 1, which is going to give me 3. On the second direction, I want to choose away from the origin. So I don't want to choose this direction. I don't want to go past the origin. I want to choose away from the origin, which is going to be down. And I want to, again, make this constant, and I want to say pegs width minus 1. And right now that's only 1, so we only have 1 row. So we only have 3 pegs right now. Because pegs width is only 2, 2 minus 1 is 1. That's 1. We'll hit OK. And we're looking pretty good. Next, we've got these rectangle sticky outy bits that we have on the side. We have them all the way around the brick. We're going to do something similar, but then we're going to add to it. So we have the bits dimensioned on this side at a 0.6 millimeter and a 0.3. We know that it lines up with the emboss. So let's go back to NX and let's get this started. I'm going to create a sketch. And instead of what we have been doing, where we have started on this inside, I'm going to create our sketch on the face of the extrude. So on this like lip feature. Again, I want to be mindful of where our origin is at. I'll go ahead and make that origin our sketch origin, just to stay consistent. Now I want to make a rectangle. And I'm just going to make it out here. And I'll go ahead and dimension this. So I want to do the length first. So the length here is going to be 0.6, and then it's 0.3 in the depth. So this side is going to be the 0.6. moved away from me. And this side will be the 0.3. Now it's dimensioned, but it's not positioned. What we want is for it to be, about right here, right? So I want it to be on this line, and you want it to be positioned to where it is on the same vertical line with the center of this hole. And well, we can do that with our make constraints. So what I want to do is I want to say that I want the point or a point on this line to be on the edge of our inside shell wall right here. And I can do that with a make coincident. I can say make coincident, and I can choose, I'll select the midpoint here, just any point on this line. And then I want to select this line here. If you cannot see this line, make sure that you are within work part only. I want to select that line, and I'll hit OK. And now our part is on that line. I can move it across, but I can't move it off. So now I need to position this so that it is vertically aligned with the center of our circle. And for that, what I'm going to do is I'll do a make midpoint aligned. And I want to select just the line right here. So this is just the line of our rectangle. And then the stationary curve or point, I want to select the center point of either of these circles. I'll select the center of that. I'll say OK. And now this is moved over, and it is now positioned midpoint aligned with that point. Remember, we want to make sure that we have create persistent relations turned on. If you don't, this will not work. And we're going to go ahead and do the same thing on this side. So we're in the same sketch. We're going to create both of these sticky out bits. So this time, this one is going to be the 0.3, and this edge here is going to be our 0.6. We're going to do the same thing where we do a make coincident, find midpoint, put it on this line, hit OK. And then we want to say make midpoint aligned. I'm just going to select this line, and then I want to select the center point of this circle. And we'll hit OK. Sketch is fully defined. That's great. We'll hit finish. And then we want to extrude these, but I'm actually going to do these individually. So I've unselected the sketch. I'm just going to go up to extrude. I want connected curves. And I'll select the curves from one of the rectangles that we made. I'm going to have it go the other way. And kind of like how we did these bosses here, I don't want to put in a value, but now I can say until next, because it actually, the extrusion collides with the bottom surface here. So I'll say until next, and I'll hit apply. And then I'm going to select the other rectangle that we made. Same thing, change the vector direction, and then our end distance is going to be until next. We could also do until selected and then select that bottom face. That works as well. We'll hit OK. And now we want to go to our pattern feature. This time though, it's going to be a little different. So we're going to go to pattern feature. The feature I want to select is one of the rectangle things that we made. You'll notice that the top also gets highlighted. That is okay. Don't worry about that. What we don't want is both of the rectangles to be selected. We only want one. See how one is highlighted and the other one is not? That's what we're looking for. It's okay that the surface is highlighted. That's fine. We just don't want the solid body highlighted as well. This time we're only going to be going in one direction. So I'm just going to say use direction 1. For this one's going to be the length. And we don't want the peg's length -1. What we actually want is a peg's length. So I will go to make constant, and I'm going to just type in peg's length. Still 8 millimeters as far as the pitch distance goes. Show results. You can see that we have 4 of the rectangles. And that's what we're looking for. We only want 4, and we only want them in on this wall. So we'll hit apply. And we're going to do the same thing for this on this side. Vector that we want is going, again, away from our origin. And this time what we want is to make constant, and we want our peg's width. Still 8 millimeters, we can show results. And we've got 2, and that's what we want, so we'll hit OK. So we've only done one side in the length and one side in the width. And what we're going to do is we are going to mirror these. But before we do that, we need to create some planes. So we'll come up here to datum plane. And we want a bisector. We're going to select this side of the brick and then the other side. And we'll create a plane in the center along the length. We'll hit apply because we need to create another one. And we will select the outside wall as the length and then the other wall. And we'll create a plane that bisects the width. I'm going to hit OK. Now we can actually mirror these. So we're going to come over here to mirror feature. It's right below pattern feature. Or it should be close to it depending on how yours looks. And the feature that we want to select, we'll select the original brick that we made. And then we're going to select the pattern feature as well. When we select the first one that we made, it only selects that individual one. But if we select any of the pattern feature ones, it selects the pattern feature itself. And you can even see on the part navigator, we've got the extrude. Well, that's the one that we made. And then the pattern feature. And that's all 3 of these. So if this changes to 6 or 1 or a million, it's going to select all of them. And then we want to select a plane. The plane we want to select is one of the planes that we created. And that's the one that bisects it on the width. We can hit show results, see what this looks like. And that's what we want. We've got the sticky bits over here. And we can apply because we're going to select the other features. So we want to do the same thing for the 2 that are in the width. So that's the one that we made. And that's the pattern feature. You can see that we've selected the pattern feature. Plane that we select is the other plane that we made. And we'll go ahead and just hit OK. Pretty confident that it would work. And there we have our Lego brick. Now before we're actually done, let's clean this up a little bit. Let's put all our sketches and then our datums all on layers and hide them. And now to test this, a kind of shortcut to the expressions that you've made as a user is still in the part navigator. You've got user expressions. And you can change these here. So we can change the peg's length to, let's say, 6. And this should auto generate. So we have 6 pegs. And if we come underneath here, so these internal embosses generated as they should. So did the rectangle bits. And so did the bosses on the other side. And we can change the width to, say, 4. And all of these bosses generated. Yep, everything looks right. See if our pegs are good. And that's what we're looking for. Whatever number of pegs or width that we change, the brick should change as well. And same thing as far as the height. So if we did a half brick, so 4.8, it should generate so that these pegs on the other side are still extending to the length of the walls, just like our rectangle bits. This is that these are going down to the floor as these are going up to the bottom of the brick. So make sure that you save this and submit it to the Dropbox on Canvas.